Hey, this is Mr. Ward. I'm going to talk about systems of inequalities. And the main way we deal with systems of inequalities is by graphing them. We're not looking for a precise intersection point. We're really looking for a zone of intersection. So if I gave you this inequality, y is greater than 2/3 x minus 1, you can see that this zone is the solution for this. The line y equals 2/3 x minus 1. It's got a slope of up 2/3. It's got a y-intercept of 1. That's a boundary for that inequality. It's not included. That's represented by the dashed line. It's not included because it's not an or equal to, but it's a boundary, and everything on this side is shaded. And if you didn't see the shading, you could test it by testing 0, 0. You could say y is 0 and x is 0, and you could say 0 is greater than 0 minus 1, because 2/3 times 0 would be 0. And 0 is definitely greater than 0 minus 1, because 0 is greater than -1. And so 0, 0 would win, and so that side is going to be shaded. So if you have any trouble with systems of inequalities, one place you may want to look is to go back to level 7 from linear and review how to graph linear inequalities. So I'm going to create another inequality, and this one is going to be y is less than -3/4 x plus 5. Now this inequality is everything below this boundary line, which is dashed. And you'll see that we've got that inequality and that inequality. And then they have an overlap area. So where these two inequalities overlap is the solution for the system of inequalities. And if I wanted to identify a point that is in the system, in the solution for this system, it needs to be in this overlap area. All points within this overlap area are solutions for this system of inequalities. This intersecting point, by the way, is not a solution because it would be on both of these boundary lines, and this is not, neither of these are or equal to. That's why they're dashed. That tells us that we are not using the line itself for anything other than a boundary. If I were, and so those lines, everything on those lines is not a solution, just this overlap. If I were to make that or equal to, then it becomes a solid line. And I make that or equal to, that one becomes a solid line. And so the lines are included. And so now the lines themselves are part of the system of inequalities. So that's sort of the basics of it. What I think would be useful in my next video, I'm going to work through a variety of systems of inequalities and graph them in these spaces. You'll be using primarily the Google Draw graphing spaces for this. You'll need to figure out what is the overlap shaded area for them. Is it a dashed line? Is it a solid line? And which side needs to be selected. So I'm going to go ahead and stop right now, and I'll start a second video next when I work these problems.